Hey guys, let's start. Welcome once again to Munich .NET Meetup and welcome to my house. It seems that this became a habit. We only have virtual meetups. Let's see when this situation will be over, but up until then, it's nice at least. I got used to it, to be honest. So today we have a very interesting meetup about how to load test and actually how to load test in a massive scale using NBomber cluster. We have with us Anton that will guide us through this. We will talk us about how to do this. And I don't think I have anything more to say. I can only say one more thing, just a formal warning. I always do that we are going to record this event, this meetup, this talk, and I'm planning to publish it to YouTube. So if anyone objects, I don't know, his name, his face, questions or something, whatever, please feel free to contact me, meetup through the meetup, or you can find me wherever you want, and we can sort things out. We can blur you out or something, do whatever possible. So yeah, let's not delay anymore. Anton, are you ready?
Yes, I think
Perfect.
yes.
Perfect. Very nice to have you here. Thank you for this talk. It will be very interesting, I'm sure of it. Yeah, I can stop sharing now and stop talking, and the virtual stage is yours.
Okay, cool, amazing. Let me share my screen and oops. Okay, share screen. Tell me that you see my presentation.
Yep.
Okay, so hello again. Today I will give a talk about NBomber, especially about NBomber cluster. So a few words about me. My name is Anton, and I'm working for a company called DraftKings. We have a business. We have business regarding gambling, meaning that we have a lot of real-time related stuff, real-time related things. We have many users, millions of users, and actually it forces us to apply some unusual techniques during development, of course. So I big fan of F#, and we're using F# in production for about 4 years already, and we very big company. My area of interest is distributed system and databases. I previously contributed in some open source projects, but my main one that I'm proud is NBomber. I also organizer of F# Ukraine conference. Previous week we just finished. It was so cool conference, and we're planning to do in a half of year. We're planning to do international conference. So my Twitter is antidev and GitHub the same. So agenda for today. I will speak briefly about the real need of load testing, then move on and discuss some limitation of popular solution, and then I will talk about NBomber. So part one, the real need. I will ask you actually, I used to ask this question on conferences. It's very super simple question, do you know the throughput and latency of your server API or endpoint? Usually, at least half of audience don't know, and they saying, no, man, we don't know. And then the punchline is how many instances do you need to have to handle 1K concurrent users or just any other amount of users? Basically, if you can answer on this question, then it's very hard to derive answer on that one. So And then the question, how you gonna scale it, based on what? Usually people talking about scalability, fault tolerance, availability, but how? So this is a tricky one. This is a tough question. Next one, when and how do you identify performance degradation? For example, you're developing something, you added some localization for your API, and then boom, in half of a year, you understood that your RPS decreased in 2 times. So the thing is that you understand it in post-fact manner. It's not cool. And then when and how do you identify memory leaks? It's also like tricky. Usually you deploy on production and you see based on some metrics that your instance is restarting 1 time in 2 days or some sort of it. It's also like it's also tough situation. Then how do you prove that your system is bulletproof and you can provide proper SLA? Also, what about POC? Usually, especially if you're dealing with a many like with a high load systems, you're doing POC, and how then you can prove your architecture? So you need POC. How you do it? I don't know. So I summarized. I just outlined all questions in this list, and the answer is simple. You need to apply load testing. And now we slowly moving to second part about limitations. The limitations of popular solutions is the following. First of all, I need to admit that if you need to test HTTP, server, API, whatever, this thing is covered pretty well. And you can find pretty solid technology that giving you nice API that represent HTTP protocol, and you can do many things with it. But I'm not really interested in it. The thing is that there is a lot of other things, like hard to cover any other pull-push system. I will later explain what I mean by this. Very complicated and not flexible API. Usually you need to learn an API or some other things, and it's still not flexible. It's hard to compose, and I don't like them. Usually it's hard. Then hard to create integration with third-party system. What I mean by this is that if you want, for example, to start fetching some metrics from Kubernetes during testing, and then render them in your include them in your dashboard, or like writing logs in Elasticsearch, or using Grafana, or write some custom sync for your data storage. All this is not free, and it's I mean not free, not like you need to pay for this, but it's not easy to extend, and it's not easy to adapt to edit. And limited cluster support, especially when you want to run different workloads, you want to change topology dynamically, and some of system like maybe JMeter, if I'm not mistaken, they asking you, they forcing you to have a master node, and this master node is doing nothing. It's just like fetching statistics and orchestrating test scenarios, but they are like wasting energy and wasting CPU. It's not fully, like, it's not efficient. And yeah, it's not easy to run some different workload. And with some with some topology that you can mix. So I said I will stop on this, hard to cover, what I mean by this, and I will just start explaining my cases. So for example, 2 or 3 years ago, we got a big problem that our tests not really sufficient, and they covered MongoDB in very naive way. We just run a lot of read requests, read queries, and we thought it's cool, it works pretty good, but we didn't know that basically every database behaving not good when you start mixing workload, when you like inserting reading in parallel concurrently. Usually for databases it's hard. And then the question, how easy you can simulate such workload? You can run like you see here, there is a 2 server that sending read request. They simulating like 2,000 users, and then the server 3 here, it simulates some processes that writing data to Mongo with maybe some timeout, some delay, but still. Basically, this is our use case. It was our use case. Then we just throw the Mongo after this. But yeah, in general, we was in quite bad situation. So what about OLAP or OLTP? When you want to take some database for POC, you need to run several your for example your queries, but plus you want to maybe compare, you want to like play with some Redis, Aerospike, whatever databases you have, and you want to run the same maybe workload, but see these like compared results. And that's the thing, there's not easy to run some to create some benchmark for databases. I'm doing this constantly. That's my need. Next one is how to model contention problem. So right now we got this issue with Redis, that Redis itself pretty fast data storage, but when you start in our case we needed to have a queue, what kind of worker queue, worker limited queue that allows several workers work on the specific resource, and they kind of fighting on this. They're fighting to get the lock to work on it. And surprisingly for us, these operations works pretty slow there. And actually, what happened? We run it for 50 machines, and it sounds like it shows pretty okay, but when you like made the rollout for many machines, we just failed. We just the Redis started restarting. We got timeouts. This is also a thing that load testing actually catching. And next thing, it's been, I guess, important for us maybe 2 years ago, and this was basically deal breaker. And after this case, I started developing the tool. So we had a system when some processes are publishing data to Kafka, and then we're fetching this data, and then we have some push server that's dishouting data to the users. So the question is how, from like regarding the latency and throughput, like what the latency between these publishers and Kafka, and then what the latency between Kafka and push server, and what the latency between push server and user. And also usually it's cool for the business to show how much time it takes to like publish data from here, and when the data will appear on the user side. Like, does it takes, I don't know, 100 milliseconds, 200 milliseconds on 2 seconds, right? So for us, it's important. And what if you want to play with, for example, instead of Kafka, you want to play with Apache Pulsar? So how easy will be just reconfigure your test and play with something different? So what if your push server, this one, supports several protocols? This is our case. For example, SignalR, MQTT, server-side event, gRPC. I can list more, but those are pretty popular. And next thing, how many connections you can handle. In our case, when we started building push system, we wanted that like one machine can handle at least like, I don't know, 100,000 connection. And in the best scenario, 1 million connection from one machine. How you can test it, how you can verify your push server that it's capable to handle it. And then the next question, what about latency and throughput? Like, yeah, you can handle, for example, you achieve this, right? So you can handle 1 million connections on one machine. So, but then what the latency, what throughput will be in this situation? Then what about message ordering? What about delivery guarantee? I need to admit that when the thing is that push systems, streaming system, it's really hard to test with current, I don't know, current popular technologies like Gatling, K6, probably written in Go. There is some Loom, or I don't recall that one written in Python. So JMeter also. I mean, it's tricky. Now the time of NBomber. So I'll explain why we built NBomber and what you can do with this. The main reason for me was to provide lightware framework. It's basically, it's not really a framework. It's I would say it's more like a foundation. Okay, it's a very teeny thing, and then on top of it, you can add more plugins and start like building a really like powerful system. So the thing is that I started, and I usually do this, I'm starting from the API perspective. In my mind, I thought I know what I want. I faced with many, like, because I played with Gatling, for example, the Scala-based tool, and with some AB tool and other things. I know what I want to have in terms of functionality, but the thing is I wanted to have a pretty simple API. I basically wanted just to have a few abstraction. Usually, if you think about this, you want to have a step and scenario. That's it. So, and then the thing is, I wanted that this abstraction would be really composable. You can reorder steps. You can add a copy step, share step between several scenarios, and without any problems. So I want to have it flexible, but at the same time very simple. In order to like give user just a few abstractions, you don't need to learn API, very intuitive one. We will really spend many hours to design it. And yeah, another goal, it was my personal goal, yeah, that since I am doing POC for different data storages system, streaming system, and so on and so forth, I want to be able to easily write a proof of concept. For example, on that case that I mentioned regarding Redis, I were able to simulate this Redis with locks, with all these things, with a lot of agents that are concurrently trying to fight for this resource. And in parallel, some agents inserted data, some agents reading data. It took me not more than, I don't know, 30 minutes or so. So it's like, I just can't imagine that this you can do this with any other tool. So with NBomber, yeah, you want to cover, you can cover pull and push system. And it doesn't have any dependency on protocol and semantic model. So you have a freedom basically. And that one third is that NBomber, we recently, by the way, started applying this technique that with NBomber, since you're writing C# or F# code, you're running .NET, you can convert your integration test, convert to load test easily. What we're doing, for example, when we're writing integration test, we separate operation like login, for example, login, logout, user, whatever. We separate them in separated like module or class, call it like you want. And then in the test, you have this operation and you have assertion. And basically, we are not like placing the whole body, the whole logic in the test method. We invoking from this test method just our operation and then applying assertion. And then we creating load test project, and half of such operation, for example, login user, logout user, we just wrap to load test environment and basically running this operation in a cycle. Okay, so in this way, like half of our use cases we just cover just for free. We're not doing really coding. You write integration test and immediately you convert it to load test. Yeah, for other rest of cases, you will need to do some specific workload for load testing to test specific thing. I do understand it. Yeah, it's true. But half of use cases you just can cover just from integration tests, and it's really cool. So yeah, and NBomber provides you flexible API, simple one, cluster support, real-time reporting, plugins, CI/CD integration, and data feed. You can inject some data feed, some data, basically random data, whatever, from JSON, from CS3. So show me code. Let me show you example. I actually having on slides, I having F#, but this one is simple. But when we jump to the visuals to the rider to show you real demo, I will use C# for this. Therefore, don't be scary. So here, this is basically API, and on C# it looks pretty similar. They are very symmetry. When I designed this, I actually wanted to keep them pretty similar. Okay, so you have abstraction step, and this is your basic kind of function. This is main one, and this step is giving you lambda function. This like from context, this one. This is lambda function, and basically what NBomber does is just executing this function in a cycle, and then after this it measure the latency. So how much milliseconds this function was executed. That's it basically. Here I am just doing delay and just waiting and simulating that I'm doing something. But here you can go to SQL Server, you can go to some other data storage database, you can put any other client here, any other driver, and just execute from here, and it will just measure it. So, and also you can return response okay or response fail. So that's the thing. Second, yeah, we add this step into scenario. And then this scenario create returns you object, and then by passing this object to NBomber runner, we register scenario. We can register many scenario, but run just a few if you want. We can specify what scenarios we want to run for this specific run. It's configurable. You can use JSON configuration file for this, and you can specify what scenarios you want to run at this time, and then for another case. You can run different scenarios. So, and then run. So basically I highlighted here, and NBomber is actually measuring this time, this function. And this is the object of response. It can contains payload, size in bytes, exception if it was, and latency. Yeah. Now it's time for the demo. Let me stop sharing presentation and let me open. Yep. Well, oops, let me zoom a bit. Yeah, I think it's visible, right? Yeah, let's start from MongoDB test. So right now I'm using Docker, and there I'm running one instance of MongoDB. So this is the test. I have a program file. All this demo projects are available on GitHub. Therefore, you can just download and run them. They are pretty straightforward. So here's a method run where I'm just using C# MongoDB driver. Okay, I'm creating database, and I'm creating basically collection users. This is my object. It's pretty simple, like just four fields. Yeah. So, and then I'm using, you see the API pretty similar to F#. I'm using step, and I'm calling the step query users, and then I'm having the lambda function where I'm doing the following. I'm querying the collection and doing some limit, and basically that's it. So I use cancellation token here. I'm passing a cancellation token from the context, and Bomber in every step, and Bomber provide the context object. This context object has a logger. You can use logger to log some information from the step. You can this is feed item. It's when I am using some data, inject some data. This item will have some type string or whatever integer, and I basically will inject some data in this step. So right now I'm not using it, therefore it's F# type unit. So yeah, I also have data. It's a dictionary. I can share some data between steps. That's pretty it, I think. And yeah, why here is cancellation token. When Bomber is stopping execution, he's canceling his executing cancel. And basically, if your driver or whatever client you use supporting cancellation, so it will automatically cancel all going requests. So it's a pretty useful thing. Yeah, and then that's, I think I defined step. Now I'm defining scenario. Here I have scenario builder. Yeah, so here I'm saying I'm creating scenario, calling it Mongo scenario, putting step. I can even duplicate this step. I can put another step, whatever. I can put pause if I want. For example, var pause step create pause, and I can put it supports time span object also, but also it can work with integers. So there is several overloads here. Time span, it supports func for dynamic injection. But basically, yeah, you can put step and put pause, and then boom. Yeah. So what NBomber will do, it will execute this step pause in cycle. So when I run this scenario, this one, NBomber will run these steps in a cycle. So like this. So it will just execute step, then pause, then another step, pause, step, and so on and so forth. Well, let me run it. So from interesting, I also specify that I don't need any warm up, and here is init function where I am just populating database. I am generating some test data. I'm not using some NBomber functionality. I'm just using some link queue and just dropping collection and populating this collection with the data. And when this init function finished, my scenario will start execute. Okay, so here I'm register scenarios. I can also have it's array. I can put more scenarios here, so I can register many of them, and then I can use configuration to say like this time I want to run just Mongo insert and Mongo read scenario or Mongo mixed scenario or whatever I want. So that I think that's it. These two fields are optional, but when you're working with some Grafana, when you want to send a matrix, it's pretty useful where you can like filter your in Grafana, you can filter your test by test suite and test name. So yeah, let me start. Oops. Oh, check. Some hotkey doesn't work. Yeah, this is how NBomber is starting. It start printing that it started, the version, and then the progress bar. And then he saying like he running simulation, and he running 100 copies of scenario. Basically, he taking scenario and multiply this scenario, create a lot of 100 copies of them, and run them. So scenarios are running in parallel. So you can create whatever many copies you want. It's a really small. Basically, it's a task.NET task. It's pretty lightware object, and this is results. Just for the record, this is RPC, request per second, and as you see, I was able running 1,000 requests in a second on my local Docker. So when you're doing integration tests, and you maybe could be afraid that, well, better to do TDD, better to do unit tests. Unfortunately, it's not really true. As you see, you can run many tests per second. And you see latency like really small. So this is like percentile, like 62 milliseconds. The max one is 150, and it's local Docker. It's I'm running it on my PC. That it's pretty good results. So what else I wanted to show? Basically, if you want, you can just open and play with all this. Here is Hello World data feed. You can find how, for example, you can read data from JSON, from CSV, create data feed, and then inject this data feed to the step. So, and then from the context, you can take the data from data feed. So it will just enumerate through the data that you have in JSON. You can, for example, in this JSON, I have a user, sorry, this one user, and NBomber is do the whole magic for me. I'm saying like, this is my type. Here is, it's because this one. I need to comment this one. Yeah, here I'm saying like I'm reading from JSON user. This is my pass. This is the data, okay? And then I can create different feed, circular, constant, that will return me always the constant value, and random, that will return me random item every time when step will be executed. So, and here in feed item, now I can have ID, name, whatever. So it's pretty straightforward and very convenient. Yeah, here you can find also the examples with logging. I'm using Elasticsearch for this. And by the way, you will find also Docker Compose here in every example. For example, MongoDB, it also has Docker Compose. You can run Docker Compose up, and all environment will be up, and you can just run the test and you see everything here. You'll get a result there. So this is Elasticsearch, and this is you set up in NBomber runner with an infrastructure config. Here you are, and basically for logging, we're using Serilog. Serilog has a lot of things, data sinks. You can use any database, Elasticsearch, MongoDB, like Kafka, whatever. You just will add the reference to your favorite sink, and then basically that's it. Or your logs will be shipped in that storage. Therefore, it's pretty nice. So yeah, for these cases, we like depending on pretty stable environment, pretty stable foundation like Serilog. I think that's it. Here you also can find example with real-time reporting. There is Grafana, InfluxDB. Yeah. So that's pretty it. Let me move on. I will continue my examples and discuss cluster in a minute. So I showed you basics regarding demo. Here is F# example with raw HTTP. It's not production ready, by the way. I just want to show you also the mechanic. So you're creating a HTTP client, then you inject it into step like a closure, and then you're just executing a sink, getting response, and then matching result. In C# the code will be pretty similar. There is, by the way, example with in C# with HTTP. So, and NBomber will just measure this Lambda function. And this is production ready. NBomber is coming with a HTTP plugin that allows you to define HTTP request in a nice kind of DSL. So you can like use headers, set some body. And yeah, it's interesting. It's pretty useful. So if you want to play with HTTP, you can get like first class API for this. Yeah, let me show you a few core abstraction. I will discuss only step scenario that I mentioned already, and that's it. And we will go to the cluster. So step, as I mentioned, you can define several steps. You can log information, what step was executed, and then NBomber, what it does, it executes them in a cycle, right? So here is output, like step 1 is invoked, then step 2, then step 1 again, and then step 2. All step within one scenario. Here you see we're creating scenario, adding steps. All steps within one scenario, always running sequentially. And by the way, probably in next slide I will show you every step after executing. Right, here's you executing and use passing value. You can pass some value, some result. You did something. You go to HTTP, fetch user login, fetch JVT token, whatever. You can return. You can pass this as a return result, but this will be also like input argument for the second step. So for example, in this step, I am passing some value, and guy from step 2, he can fetch the value. He can fetch the result via using get previous step response, and then he can print it out. As you see, this is a result, console output. Here is 42. So same step could be hosted differently. As you see, there's 2 scenarios, but I can put step 1, step 2. I can reorder them, whatever. I can reuse it. It's pretty composable. This is really what you're feeling freedom when you're writing it. So it really gives you really powerful flexibility, but in terms of API, it's quite simple. Step, scenario, and what you're doing also is probably playing with context. That's it. Yeah, now scenario. So scenario helps you to organize steps basically into sequential flow. You're getting sequential flow. And then what scenarios does, scenarios allowing you to set different basically slot simulations like concurrency control. You can set like ramp up, inject, ramp constant, keep constant. You can set rate. You can set copies. I wrote a page about this, about load simulations. I don't want to discuss it right now. It's pretty like deep topic. I encourage you to read about this later, but yeah, it's pretty interesting. So basically, these load simulations allowing you to simulate different workload. There is cases where you have finite amount of machines. They're constantly working with some resource, and there is cases like you designing Amazon, and you don't have finite amount of users. The users are constantly changing, new users are coming, and your server can't, and every request is not waiting for response from previous request. So basically every user is sending request, and then then it's modeled as a rate. You're saying rate, but there is things like load simulations like constant that allowing you to say like I have just 10 copies and that's it. These 10 copies are working and they are like waiting on each other. This load simulations modeling closed system where you have finite amount of clients. Yeah, and all scenarios always run in parallel. So you can have several scenarios, you register them, and then you run, and this one, they will run in parallel. And then in NBomber, what it does, it will create many copies of this scenario. Here, you're specifying, you're creating scenario, load simulation, and basically here, you're specifying 10 copies. This scenario will be like multiplied on 10. Basically, 10 copies of this scenario will be run. You can configure it. There is a JSON file for this JSON configuration. I also described this on documentation, and you can play with it. So usual setup for NBomber, at least how we use NBomber, it's send logs into Elasticsearch. We can look at them. It also it can save also to the file by default, but you can add more things. Since we're using Serilog, you can store your logs in any other storage. Also, we save metrics into InfluxDB, but there is a plugin for Prometheus. You can use also this. And then, yeah, we run our API or database, whatever system in Kubernetes, and then just attack this system. Now it's time for NBomber cluster. So I have probably 20 minutes. So yeah, the cases. The cases. Basically, I mentioned about MongoDB, you remember? And let's say I want to simulate this workload. We have two servers that simulating users, and they basically sending a lot of read requests, right? And then another one, a third one in the left corner, it sends write request. So basically, in NBomber, they said two things like coordinator and agent. So the cluster consists of two main components, and the main role of coordinator is he actually orchestrate tests and between agents. Via coordinator, you can change the topology. You can, for example, say this time I want to run this workload. Next time I want that this guy, agent one, should start inserting data. Agent 2 should start inserting and reading in parallel, and this guy will do nothing or will read data. You can change it dynamically, just restarting the coordinator. You don't need to restart agent. They just very kind of static guy. You run it and that's it. And boom, the coordinator for each run, it will spread the configuration to these two guys. And every time basically it will be new configuration. They will read it, apply and execute. That's pretty it. The thing, how they can communicate, how they know about each other, we're using message broker. And basically message broker is necessary for service discovery. And also coordinator like orchestrate. He send a start command and then all agents starting attacking. Also he sends stop. They are stopping, gets statistics and so on and so forth. By the way, he's not actually saying stop. Technically speaking, when he sent start, he also sent the duration. Duration, by the way, could be different for different agents. And then when they working and duration just ended, they just stop it. So, but yeah, coordinator can do for some use cases. You can, for example, you run something but then you figure out that you miss some properties. You just rerun coordinator and he send the stop to this agent. They're stopping automatically and then just reset their state and then they starting another test. So what the difference between coordinator and an agent? So basically you have a file, you have a code. Here is your test. It could be C# or F#, doesn't matter. You compile it. Then you got some exe or DLL file. And then you upload this file on machines. And the difference is they are identical. The code here is identical. Here's some tests and here's some tests. The binary itself identical. The difference is the attached configuration file. You can put agent config and coordinator, and by this basically they understand who should play which role. Basically, this is example of JSON configuration for agent. It's pretty short. Here I'm saying it's a cluster config, and I'm saying I'm agent, and here I'm saying cluster ID is NBomber cluster. You can put whatever you want. Because when you're using the same broker, you can run in parallel several clusters of NBomber, and they communicate through the broker. By the way, this schema with the broker is very convenient because you run this broker. It should be not powerful machine at all. This data matrix, some sort of it's sending not often and it's not. It shouldn't be powerful. You can run it on one CPU. Well, but the IP address is kind of constant. It's publicly exposed, and if you're running in Kubernetes, for example, it's really convenient. But because every restart, every killing NBomber cluster or resetting it, you're always having different IP addresses, whatever. But this guy is pretty constant, and when you referencing the address here, MQTT server, I'm using MQTT broker. I will show it. So the address will be kind of static always, and it's convenient. So also thing is that agent is by default should have a group. I'm assigning, for example, these guys when they starting, they assign for agent group 1, and this guy for agent group 2, and in this way I can like run different topology. I can say like the guys under agent group 1, they should start inserting data to the Mongo. The guys from agent group 2, they start reading it. And this is example of coordinator. The difference here is that this guy is coordinator, clusters the same, ports the same, but here I'm saying target scenarios. These scenarios will be run on coordinator itself, and this is array. I can put much more things here. I can say please run Mongo insert and also run Mongo read. I can mix them. I can mix workload. And here I'm specifying agents. I'm saying target group 1, and target group 1 will run this scenario, Redis. So I can really mixing many things together to simulate real workload. Here I'm inserting data to Mongo, and let's say the data from the Mongo will be moved to the Redis through the Kafka, and then these guys are constantly reading data. They can like validate consistency, whatever I decide. So it's really really cool. Yeah. So the demo time. Demo time. Let me show you what I have. So I'm running. Let me zoom a bit. Oops, sorry. I'm running Kubernetes, and I'm running. We'll test the Redis. Here is my broker. I'm using MQX. This is a dashboard of this broker. It supports WebSockets. It supports TCP, whatever, and it's MQTT broker. It's broker designed for IoT. We're using this extensively, and it's really designed for high load based on Erlang. It's one machine in enterprise version can handle 1 million connection, like 16 CPU, and I don't recall how much RAM should you have. So, but yeah, it's really cool thing. Way better than RabbitMQ and any other that I know. We especially load tested this guy before started aggressively using it. I'm using only one CPU machine here. I don't need to have some powerful machine for this. Also, I have NBomber agents. I deployed already 20 guys, and here is my Redis. I'm having Redis master. I'm using a cluster of Redises with on very slow machines, and basically there's 2 slaves. They probably limits 1 CPU for every pod. And what we will do, we will simulate that workload where we inserting data to the master, and then many agents, these guys are reading data from the slaves. Okay, so I especially did the following. I exposed master IP address and slave. My agents will connect to this guy only to slave. They will not connect to the master, and basically constantly trying to fetch data from the slaves. What I should now open. I need to open, my demo project. So this is a NBomber cluster, and here is my demo. What I wanted to show you is this. It's a Redis write reader test, and let's start from writer. Basically, if you go here, so what do we have here? We have writer scenario. The writer scenario will write data to the Redis. We have init function. Init function is just populating database. This code is written in very imperative way. In F# I am writing a bit different, but for C# it's pretty okay. So here on init, I'm fetching configuration from the NBomber context. I'm deserialize it, and use it in a variable scope. Then I generate some payload, okay, just random payload, and then here is I'm connecting to the Redis and executing this populate database. After this init function finished, and now I can start my attack. So this function returns me scenario, and here I'm defining a step. So step called write, pretty straightforward. And here I'm taking database. It's very cheap operation, and I am trying to randomly, basically create random number, and this will be my key, and then basically start insert data. And on next iteration, I will create another one, another key, Redis test key, and just set another chunk of data. And on response, I am returning okay. If everything fine, if error will be or exception will be thrown, NBomber will log it, and I will see this like fail counter 10 or some sort of it. So also I'm adding pause because I want to simulate our use case. We're doing pause every like half of second or sort of it, and after this we publish data again to the Redis. So basically execution will be step pause like this in a cycle, right? That's it. Just you see how just I have in here just a few things: step, pause, step, and scenario. And now I don't even set any configuration. So let me show the reader scenario now. This is reader scenario. It has its own configuration. I will show it later in JSON how it looks like. But yeah, mainly you should focus on init step. I'm getting my configuration. I'm creating Redis client, and that's it. And this is my step. This step I call it read step. I'm getting database. It's cheap operation. Then randomly I creating some key from some key range. You see, it's not like I'm just creating random number. I have pretty like limited range of keys. I just want to simulate random access pattern. So, and then I'm just getting value and writing value in response, and that's it. This is my scenario. I call it Redis reader. That one I called Redis writer. So let's take a look on configuration. Here is configuration. So agent in pretty simple one. So I'm saying just like it's cluster config, it's agent. Here's ID. Here is my IP address of my broker. I showed it already. This guy, this is a broker, yeah. And here is admin panel. As you see, agents already connected. So it's basically Docker containers. I just run them, and then on the start, they reading, okay, I'm agent. Here's my host. Here's port, and then they connected, and then they also know that they assigned to target group 1. Now the coordinator. This is a coordinator. Yeah. So we right now interested mainly in these cluster settings. So here I'm saying I'm coordinator, and the same port, the same cluster ID, but here I'm saying what scenarios I want to run on coordinator. Since I am running coordinator, it's like a main node, like master. Yeah. So coordinator is one single node, so it's like singleton. And I'm saying, okay, from coordinator, I want to just start inserting data. Okay, all other agents will start reading data, but this guy will just insert. And here I'm saying like agents target group 1 will do Redis reader. Target group, I can create like target group 2, for example, and specify, I don't know, publish some, if I have some scenario Redis, for example, I have Redis writer, they will do inserting. So, but here in agent, I need to like have some agent who is target group 2. Yeah, in this way I can like change topology. So, and then here is settings of every normal NBomber configuration. It's a pretty standard configuration of general NBomber, not a cluster one. So if you download NBomber right now, all this configuration is available for you. You can do the same. So you specify scenario name Redis writer. Let me open it. Yeah, here you are. This guy's writer scenario, and you see the name is Redis writer. So in configuration, I am saying scenario names Redis writer, warm up duration just 5 seconds. I can remove warm up if I don't need this. I can do whatever I want, but let's leave it. So here I'm saying load simulations. I am saying like keep constant, keep five copies of this scenario of writer. So for 30 seconds, it will create 5 copies of this scenario and they will run 30 seconds. And then this is custom settings. This is section, you can skip it if you don't need, but this is section is basically entry point for you to configure, to inject your custom configuration, different connection strings for from different environment on staging. You can have different IP addresses and ports, or you can play with, I don't know, with pause delay or key range count. You want to play also with bytes. For example, now I'm sending 1 kilobytes, but I want, for example, on next iteration, I want to send 1 megabytes, whatever. It's easy. How it will work, you change this configuration, you save it, run only NBomber coordinator, and NBomber coordinator will dish out this configuration between agents. Agents, actually, they don't have any configuration except this JSON. They don't know anything about this payload size, some delays, whatever. Every time they're getting this configuration from the broker, from the coordinator sent to the broker, and then broker dish out to the agents. That's pretty it. So I think, let me show you this custom configuration. Here you specify JSON, and then if I go to write scenario, I define this on top, this write configuration. You see, it's similar. It's basically reflecting that JSON, the JSON file, JSON node. Payload size in bytes, write, key range count, and then NBomber through the context, giving me custom configuration get, and I'm specifying this section, and then boom, I'm getting configuration. That's it. So the same for read. Here is configuration for read. Let me show you it here. This one, just 2 fields. Yeah, and in read scenario, I have only these 2. So I'm reading. So I'm running out of time. I need to start showing you. So I think we're ready. So let me show you. Let me open my control panel. Yeah, this one. Oops. Yeah. This is the node where my NBomber coordinator sits. And from here, I am running my project. As you see, I am executing my demo DLL project. And the difference, I am specifying the path to config. If I specify here agent, JSON, whatever, it will be executed as an agent. But here I'm saying it's a coordinator. And also I am specifying infra configuration. I forget to mention about infra configuration. Later on, I will show you. So let me run. So NBomber is saying NBomber cluster started. Here's a version. And now he's saying, he printing configuration, and he's saying available agents, 20 guys available. Now this 20 guys will start attacking. I also basically, they run warm up. Now they waiting that all agents finish their warm up. And now after this, they start bombing. So we can wait like 30 seconds, but in configuration, I said like, Redis reader, this guy, I am saying like, please run 100 copies, meaning that I have 20 agents, but these 20 agents, each agent simulating 100 concurrent clients. So 2000 concurrent clients together. right now attacking our Redis. Yeah. So yeah, we already stopped, and now NBomber just waiting on the results from agents. Basically, this case a bit tricky since with Redis and the payload of 1 kilobyte that I'm using right now, the latency is pretty slow. And basically what's happening that I'm creating a lot of tasks. And when I want to just stop all this execution, usually the agents is pretty busy and they need to clear to stop all these tasks, and therefore time to time takes more time. You need to wait a bit. Yeah, but if you extend the delay, put the bigger size, for example 1 megabyte, or I don't know 100 kilobyte, the stop the stop fast will be faster, because just a few tasks will be run. Because if you add more tasks for .NET runtime, it's harder to stop them just immediately. So here is the results. As you see, Redis showed 55,000 requests per second with this latency, like pretty okay. It's less than 100 milliseconds. I can rerun it. And also, I just want to show you, I run also ping plugin, and ping plugin to the master node and Redis slave node. And it's really important information for me when I'm testing to understand that in environment where everything is running has low latency, because I don't need to like run some test from Europe, but my target system located in US. So the latency will be huge here. So this guy is basically showing me that the latency is quite small and everything is fine. I forgot to show you some dashboards here in NBomber documentation side. We have documentation. Yeah, you can read everything here, but also we have changelog, and I'm basically putting some information regarding changes. And we recently created a new dashboard. It's just example. Yeah, this dashboard showing you some load distribution, and it has nice bars. You can see throughput, you can switch between steps, and also latency diagram with percentiles. Well, pretty standard functionality. And also, yeah, it shows also results of ping plugins. As you see, that was some test that I'm showing, and here the latency round trip is 26 milliseconds. It's a huge one. Usually when you're running load tests, you want to have like 0 latency or maybe one millisecond. So I think, yeah, here is my ping plugin. It's infrastructure configuration. I'm specifying Redis master and Redis slave and some timeout. This is pretty standard ping plugin. You can find documentation about this. Yeah, my application, as you see, just like explain you what NBomber package looks like. Basically, NBomber package or application contains many scenarios, but then you don't need to run all of them. Using configurations, you can create a file per some specific use case, and you can compose different scenarios in one kind of configuration and just execute them. It's like a deployment in Kubernetes, some sort of it. So and basically, yeah, I'm just specifying when I'm running it, I'm just specifying the path to the file. For example, next one, I can run coordinator 2 that attacks not Redis, but MongoDB or MongoDB with Kafka, whatever I want. And I can put different infra configuration file that will have configuration for serial for Elasticsearch instead of something other storage, or instead of InfluxDB, it can use Prometheus. It's pretty easy to configure. So I think I finished with a cluster, and just a few words. I'm finishing already. I have maybe 1-2 slides. What else do we have? Here is basic plugins that we are working now. They not all of them are complete, but just want to share our vision. So HTTP plugin is complete. You can use it. It allows you to write first citizen HTTP tests. Push extensions provides you a few abstractions to define push scenarios. I actually wanted to show you push scenario. For example, that MQTT broker that I mentioned, I wanted to run like 60,000 or something connection and just show you the latency, whatever. But I just see that I'm running out of time. So maybe later we will have another session and I will show something else. So InfluxDB sync, you can take it. It's already on GitHub. We use it in for more than about 2 years or a year and a half. So the database benchmark, this is pretty unique thing. It's a plugin that can simulate you different workloads, and basically you can test different databases. For example, you want to run this workload with, for example, OLTP workload with transaction, with logs, with some customers, whatever. You want to run it on Redis, and then you boom want to run it on, I don't know, CockroachDB or Aerospike, whatever database you like. So K8 metrics, and also you will be able to plug in to write to use your own database driver, for example. I don't know, whatever you want, and basically you need just to implement the callbacks that we will invoke, and basically that's it. So K8 metrics, it's interesting plugin that allows you to fetch and render metrics from K8 and apply assertions. I will later show you it. K8 House Monkey, it's plugin that helps you to inject some faults in your Kubernetes environment. The thing is that you can use all this and you can have metrics and you can use House Monkey. The thing is that with NBomber, you got one single HTML file and all reporting will be in one single point. And for you, it will be way easier to navigate, to understand, at this point we stopped one node. One node is crashed and the load was decreased or some sort of it. So it's way easier than having different, Grafana graphs, because we actually working with the Grafana, therefore that's why we created it, because it's not easy to navigate. That's the thing, that NBomber in this case, you're running your environment here in Kubernetes, but then in parallel NBomber fetching metrics, and then it do some calculations on statistics, and then you can apply assertions. For example, you want to run a test for 30 minutes and understand that your API doesn't have any memory leak. How you can do this? It's not possible without, right now it's really, really hard. Here, you can run your API, send a lot of requests, and then after test finished, you can apply assertion, and then you can see CPU latency, CPU percentile, max CPU, RAM, whatever you have, and you can apply assertions based on this result of metrics. In this case, you can actually see that your CPU is not growing even if you increasing the load. It's pretty cool thing. I don't know who doing this. I never seen the similar functionality. Just want to, I forgot one thing. Just want to show you the configuration regarding assertions. I think this one. In NBomber you can run test assertion. This is how basic test looks like. So you have a test, some X unit. Here is NBomber, and then you can do your assertion. In C# it looks different. You're using some Fluent assertions library, whatever. But basically, that's pretty it. So, and you can have then CI/CD pipeline. You will catch all this, late degradation of feature. For example, you're implementing some feature, and then your load test running at night, and then you can catch that this feature, some translation that you applied recently, whatever, it works slowly. So, NBomber helps you, and it's really cool practice when you apply load testing in with CI/CD pipe. Put load testing in your CI/CD pipeline. So I think I finished. I don't have much to say. There is a couple of links on NBomber and documentation, and a link on F# Ukraine conference. You can take a look. Yeah, now I'm open for the questions if you have.
Wow, nice. Well, a lot of
Thanks.
information, and I definitely need some time to digest all of it. I need to start playing around in order to own it. But it was very, very interesting. Question, guys. If
Thanks.
anyone has anything, please feel free. You can take some time to think about it. I just had a question based on the last. First of all, I really enjoyed the fact that you're actually writing code, right? You are not clicking around and drop down menus and try to configure it.
Yeah,
You're actually
yeah,
writing code. And this is, at least for me as a developer, this is something that I miss. I really like it.
yeah,
And that brings me to a question based on your last slide, or I think it was the NBomber.com site. You should easily be able to convert integration tests to load tests, right?
yeah,
It seems that we have, for example, in my company, some X unit tests that we are testing. We are attacking directly an endpoint to test a few things there. And that means we can just add the NBomber package and convert it a bit. And that will be,
yeah.
let's say, almost automatically converted to a load testing.
Yeah. We're applying this practice. Yeah, exactly.
That is,
50% of our use cases is exactly like this. We're having, the thing is that you need to first ask your team who is writing integration tests that they need to write a logic, basically some operation in separate module. And then in integration test itself, in the fact, or if you're using X unit, you invoking your module with operation, and then after this you're applying assertion. So you are not writing the whole meat, the whole code within the test method. You're just delegating it to this module of operations. And then basically for load test, you taking this operation and execute wrapping in step in NBomber, and that's it. Because step is just a lambda function. You can put whatever you want there.
yeah,
So
cool.
it's
That's very cool.
pretty. Again, I'm saying we covering a lot of complicated workloads with NBomber. That's was really hard to achieve with any other thing. And yeah, there is a probably the most close framework. It's a Gatling. It's really good one. It's based on Scala. It's also very kind of flexible, but they're actually covering API, HTTP, and even with this, you need to learn their API. It's I don't like this, and if you want to extend it, we, for example, previously we used SignalR maybe 4 years ago, and we wanted to use we took Java implementation of SignalR, and we just stuck. It wasn't worked at all. So it was
Yeah,
hard to integrate in Gatling. Here, it's everything in native. You just take a client, whatever you want, and play with it. And by the way, also I need to admit that usually if you take in some system and with systems, people also sharing some benchmarks. This is very tough thing. You can see benchmarks, but when you start running this from .NET, you will see that the results will be different, because even a few years ago there was a famous fact that the MongoDB driver in Node.js worked faster than C# one, because MongoDB driver in Java in Node.js, they used C++ under the hood, and C++ used better memory, more efficient way. Like 3 years ago, MongoDB driver in C# worked slower comparing to JavaScript. And you can open the GitHub, you see a nice result, but then you boom started playing with C# and it's not showing you the same. Therefore, you actually need to test exactly your driver. That's the thing. With MQTT, we also got the same. There were recent optimizations into the driver, and now the driver showing better performance. They're using memory span, whatever, but it was just this change was recent. So previously, the result were not comparable to some, I don't know, Go driver or Erlang driver. So therefore, you always need to test your driver implementation. That's also the thing. Yeah.
cool. I think Mark has a question.
Yeah.
He says, I created new step. Does master can spread it code not config to all cluster nodes? if you create a step, master will spread it to the cluster nodes.
Yeah, I'll explain. So the thing is that I will scroll back a bit. Oh no, it was here. Let me. Yeah, here. So basically, your master or your agent, they are same binary. It's not like if you played with Erlang that you can write some code, and Erlang runtime, since it's dynamic language, it can basically take the code and send it as a string, and then on other nodes they will fetch it and compile and execute. Here I'm not doing this. By the way, it's possible with F#. F# has way better support for for expressions. There is a feature expressions in C#. In C# expressions are not serializable. Therefore, you can't just serialize some expression and share. But in F# it's possible. But still, it's really tricky one. Yeah, in F# you can do this. In C# not. But we are not doing this because it's not really giving much value in nowadays when you have Kubernetes. You just build the source code. You just compile it, create a package, upload this package in Kubernetes, and then you just specifying a different configuration for file. For this package, use agent config. For this file, use config coordinator. And what master node or coordinator that I'm calling, what it does, it just spreading configuration file. So these things, this is what I'm saying on the picture. So let me show you it within the code. Yeah, these parts. Basically, it takes this file, this one, and create just a string and send this as a string to all agents. And all agents, they're just parsing and just mapping to their compiled sources. For example, they see, this is configuration for scenario Redis writer, and I have Redis write or Redis reader. Sorry, I have Redis reader here and Redis writer here. So basically they have everything. They have codes, binary, but they just need to apply a bit different configuration, and they're applying whatever coordinator or master specified here. That's how it works. So basically only configuration file are spread at every time, like introducing some dynamic manner. And it's very useful if you want to, like, play, build a playground, play with different settings. Now it's kilobyte, tomorrow it's megabyte of data. So you can do this without any restarts, whatever. You just stop coordinator, change configuration, run it. That's it.
Nice. Anyone else, guys? Feel free. Just before, I don't know if you will have any other question from the people that are watching us. It seems that, again, I'm new to this and I'm trying to understand. But anyway, it seems that you can test everything, like I don't know, gRPC or WebSockets or whatever, GraphQL, right?
Yeah, you can test any possible thing. Because you don't have any dependency, you just plugged in your client, and you can test whatever you want. I'm just thinking, do I have something except maybe MongoDB? For example, this is this is HTTP. This HTTP is already using a library. There is no simple one. I just wanted to show you the simple HTTP client. Yeah, but with Mongo, for example, it's the same. You're just creating some collection and inject this collection into step. That's pretty it, and that's it. You with gRPC will be the same. Yeah, the push, how we test the push, it's a bit tricky. I need to explain the kind of complexity, what complexity you can see with push in general. It's a bit different because it requires probably 20 time of just explanation how NBomber does, because it's adding some magic in order to simplify many things there. But yeah, we're doing we're using Kafka. We're testing Kafka. We have cases where we have several workers, and one worker is publishing data to Kafka, then another worker fetching this data from Kafka, modify and persist again, and then this data should via WebSockets be available on the client side. So when we measuring the whole flow from point A to point C or something, it's like easy. I mean, you can cover it with some other thing is hard. But by the way, I just wanted to mention that if you want to have to create some tests that your automation guys will be able to do without much coding, you can do this with JSON. You can have you can create HTTP test like this, like this one. Like this one. Here I'm creating HTTP step. I'm taking request. You can do with body. You can place body different. You can put check if you want to check so that response is okay or not okay. And then you can use configuration. You can use JSON file, and basically your automation guys, they can just start placing different URLs. So this URL could come from some configuration file, and that's it. In this way, you can kind of automate some simple things. You can just it's like playground, and then they just can just take JSON file, modify URL, modify maybe something, and also they even can put some simple validation within this JSON file, some values that I don't know identify that the data response is okay or not okay. It contains user ID like this or not like this. You can do some simple things with this.
Cool.
Yeah, but I need to admit it's actually designed for developers itself, because it's really we running big company, and it's hard to say, but usually from automation, the guys can cover very basic things, and usually they will in details, and usually the developer then catching all other stuff. Therefore, we need proper instruments for this.
Yep. Well, personally, I enjoyed that is written for developers because it's more code, right? We all enjoy writing code. And you could actually, I know that it's kind of impossible in theory anyway, but you could sort of even test thread safety for your code. I mean, at least having a chance of actually finding a problem there if you are attacking it in parallel.
Yeah. You know, the interesting thing which we really recently identified, I mentioned this, but I will just repeat that the memory leaks. For us, it's we designed a lot of stateful system, not stateless, but stateful, for performance reasons. And usually this system way harder to design. You have things like back pressure there, you have always like memory leaks, whatever. And it's hard. We just see that, wow, on production, some server restarts one time per 2 days. It's hard to catch. Like you need to wait 2 days, download something. And the thing is that it's post fact. It's like you deployed it. With NBomber, what we do, we develop something, we deploy in Kubernetes, and then we kind of start bombing this test, this API, whatever, for, I don't know, 30 minutes, for example. And in parallel, NBomber is fetching metrics. And then you can do assertion. I don't have examples on this, but you can think about this like, for example, XUnit example. Let me show. Yeah, this is simple example with XUnit. This is a test. Yeah, this is scenario. This is NBomber runner. I'm register, and then I got some statistics. We call it node stats because this stats from different nodes, and I am fetching scenario stats. I can filter by name here because it has everything. I can filter by name and get some step because I can have several steps. Here I'm getting step 0. So and here I can have OK count, I have many mean, percentile, whatever. In the same way, I have metrics from Kubernetes. I can apply, I can see that CPU during testing was really high, like 2 CPU instead of 1 CPU. The same for memory. So it's really cool. We actually able to catch now memory leaks. Without this, I don't know how to catch it. I mean, it's tricky.
It's very tricky. Actually, all these kind of problems that you have to wait a couple of days either for a correct thing to happen, or because of a memory leak, or I don't know, whatever, you can try at least to compact these 2 days into an effort, into a few minutes or something. Yeah, these race conditions or memory leaks or whatever is always difficult, very difficult to catch.
True.
Yeah. Cool. I think there is, there is a question from Daryl. Does the working agent push any metrics as well? For example, if the agent's machine is running out of memory or maxing out CPU, it can skew the results.
The agents, it's how the cluster works. Let me this picture is actually describing. So during running, the coordinator is send request, please start. They warming up. Then they send responses that they finish, everything fine, nobody failed, everything fine. And then they starting. And during attacking, these guys are calculating metrics, but they are not, they sending these metrics in different period. It's configurable. I can show you how you can configure it. And basically, you configure this. Let me show you it. There is a real-time metrics. This is exactly the case. You can play with it. Here is a very simple scenario. And here I am using InfluxDB. I am hosting Influx on localhost. And there is Grafana also. This is a Docker Compose for this. In this folder, you can find Grafana, InfluxDB. So, sorry. Yeah, and basically here I'm saying with report, here I'm defining registering my scenario, specifying name, and here I'm saying with report sinks. And this is array. You can specify several reporting sinks. One guy will send metrics in InfluxDB. One guy, another guy can send in Prometheus. Another guy can send, I don't know, in some file, whatever you want. It's very flexible. And here I'm saying send starts interval. I'm specifying send metrics one time per 10 seconds. So the guy is sending one time. So, and actually, what coordinator does, one time per 10 seconds, he sends request to agents, like, please give me your current metrics. And then they are returning you back. The question was about some memory CPU issues on the agent.
Yes.
For now, they don't. They just sending metrics regarding some test execution, how many bytes they transferred, how many errors they got from scenarios, some sort of it, but not about their internal kind of environment. So but I think we're gonna add this too, because it's also useful. I just don't have much time to to implement all this. We have many cool ideas for our further releases.
Okay, so that is on the to-do list. That's
yeah.
Perfect. Very nice. Now it's very interesting for me, and actually what I really liked, and I said that before, but anyway, it's how easy you can convert your integration test to load tests, because it's like you have it ready. You just need a few clicks here to change a few things, and you have load testing.
You know, the thing is, just think about this. I am willing to prepare a talk which will call TDD is almost dead. I am pretty confident in this. The thing is that integration test, I showed the example with a MongoDB. You can run like 1,000 per second. Yeah, the data size, the user object was pretty small there, like 5 or 4 fields, but it doesn't matter. It's still big numbers. Like even if you run 100 per second, it's pretty enough. So in a Docker, you can run many integration tests. This is one thing, and you can cover many things. Another thing is that your integration tests, they really much simpler when you're reading them comparing to any C# like mocks, whatever you set up in something. Here, if you're testing HTTP, especially, it's like 80% of cases is just HTTP API. You're making GET request and then you applying assert on response. They are very, very simple. They're very readable. And the thing is that they are not really depending on the code. You can refactor code, but you don't need to touch tests. With TDD, you constantly touching tests, you refactoring. You refactor code, you go fix test. You refactor code, go fix test. With integration, you are not. You don't waste the energy on this. You write pretty simple integration tests. They are readable and they are very fast. The thing is that you need to keep it in mind that they should be fast. For example, we're designing them for Kafka, for example, we're doing some hints to run them in parallel and have them really, really fast. So with databases, usually it's not a problem. Since in Docker they work pretty fast, but yeah, then you got another benefit. You can catch memory leaks with load testing. You can do load testing because you can write some code that will go to make a login to database. So the test is green, everything fine. But when you run load tests, you see that this test you getting, I don't know, 5 requests per second, very slow. So this is way better than just spending energy on TDD. This is way better. And they are not false positive. Your integration tests are real. They're showing you real things. And your integration tests, usually they based on contracts. Contracts is pretty stable. That's why you're designing, you're thinking about contracts. With TDD, you constantly in this rush that you refactor something, you go fix it, you got false positive on production, it will not work, whatever. It's way better to spend, if you have some limited time capacity, is way better to spend it on integration tests than half of this integration test you convert to load test, and you have all this in CI/CD pipeline. You run this load test from Jenkins or some other job, TeamCity, whatever you use, Azure, whatever. So it's pretty easy to integrate in your CD pipeline, and they showing you real things. And your team who is developing it, they starting thinking about different aspects of programming in general. That this guy can go down, what then will happen? So when you just writing TD, you don't think about this at all. So therefore, we preferring write integration only. We very rarely using TDD in general, very rarely. Only when we want to cover some algorithms. For example, we developed database. We're developing right now database, and for this database, we having cluster, and we have replication, and we have after failover, and these algorithms should be tested. We write some integration, but also unit test for this, because they are distributed. There's many things you can catch by unit test also. But for other systems like API based, business based system, it's way better to just use integration tests, run it fast, tune it to be run it fast, and use load test also to catch memory leaks, all other things. Therefore, that's the thing. They are very, very useful. We completely changed our vision on TDD or all these things. That we basically stopped to think about this as it's really important. It's deal breaker. It's not deal breaker at all.
Yeah, well, I completely agree. Actually, I wrote a blog post maybe even a year ago about exactly that, how much I prefer integration tests and how to actually do integration tests in .NET Core APIs. And I completely agree with you that I only use unit tests nowadays for either if there is any complex code that I want to specifically test that part, or if there are, I don't know, runtime error prone code, using reflection in some part, or I don't know, calculations, for example. There are very
statistical calculation.
There are very specific things that that I write unit tests. Everything else is integration tests. So these tools for me is a perfect match for my coding style, let's say, to actually integrate load testing. Yeah, it's super.
Therefore, we even calling like TDD is almost dead, and your new kind of combo is integration plus load test. It's your new combo.
Yeah, totally agree. Totally agree. I really enjoyed it. I would be happy if we could have a meetup in the future. I don't know, about some other practical aspect. actually converting integration test to unit to load test?
Yeah, easily. I can prepare something even more interesting. And not only this, I'm doing many things regarding architecture, especially in high load scenarios. I can present something. Yeah,
Perfect.
we'll
I
contact
would
you.
really enjoy that. We'll talk.
Cool, guys.
Guys,
Yeah.
if there is no more questions, just a reminder, in 2 weeks from now, we have Hanselman. I was trying for quite some time to actually have Hanselman for a talk. And now it seems maybe, I don't know, the coronavirus situation helped a bit because it will be a virtual meetup. He will be in the United States, will be here. Yeah, it's already 100 people plus joining this meetup. So I will probably change it from Zoom to something else. I'm talking with the .NET Foundation to help me out there. So feel free to join in a couple of weeks. Anton, thank you very much for this talk. We'll surely talk again, probably after the new year, in the new year sometime.
Yeah, sure. Thank you, guys. It's really pleasure to give a talk here. I'm really like it. So
super. As
next
I said,
time.
I will publish everything in probably tomorrow. I will just leave 24 hours or something to, if someone disagrees with that, we will have some time to actually express his disagreement.
Sure.
So I will publish it tomorrow. Yeah, stay healthy, stay safe, and see you in a couple of weeks. Ciao.
Yeah, cheers. Yeah, cheers. Bye-bye.
Bye.